Over the years, many researchers have tried to define what artificial intelligence is. And sometimes we don't reach a common agreement, and they have come up with different ideas that are sometimes in conflict. So, some people say that artificial intelligence is about being human, others say that is about being rational. So, they define this concept of rationality, which means to make the best possible decisions, to make the right decisions. And it doesn't really matter if they're human or not. For people who see artificial intelligence as a proxy for rationality, it doesn't really matter if you're being human or not as a machine. Another important difference is how we measure intelligence. So, some authors say that we should focus on behavior, how the system acts. But others say that we should care more about thinking, what happens inside the system's mind. And this actually seems the same concept, but it's actually very different, as we will see, because externally we may act intelligent, but internally we may not be intelligent. Okay? So there's this difference between the internal world of the system, of the machine, and the external world. So we have two dimensions here. If you were paying attention, the first dimension is being human versus being rational. It's about being, and the second dimension is about thinking versus acting. So internal or external behavior. And when we combine these two dimensions, if we put two axes, we can see that we get four different ways of defining artificial intelligence. So it's actually very interesting to see each one of the concepts because they're quite different and sometimes they enter in conflict with each other. So let's look at each one. The first approach is to act like a human. And this approach says that an intelligent machine should behave like a human. And how can we evaluate that if the machine is behaving like a human? Well, there is a classical test that made this approach, this dimension very, or this concept very well known, which is the Turing test. And basically, if you can pass the Turing test, then you can say that the machine is acting like a human. And the test was proposed by Alan Turing in 1950. And the idea was quite simple. So imagine that you have a machine, and the machine is in a conversation with a person. And the person cannot tell or cannot know if they're talking to a human or a computer. The only thing that they can have access is to the answers of the machine to questions that the person may have. If the person is fooled, if the person who is the judge is fooled by the answers of the machine, then the machine can be considered intelligent. But there's a point here because the person will receive answers from two participants, one that is human and the other that is the computer. So it's not just about me and the computer, it's about me, another human, and the computer. And the judge, of course, doesn't know who is who, like I said. If the computer can consistently fool the judge, then the test is passed, and you can officially say, okay, we have a system that acts like a human, that has the behavior of a human being. But to achieve this, the computer needs several capabilities. Nowadays, we have ChatGPT, which most likely will succeed in most Turing tests because, first of all, it can understand and it can generate natural language. So he can do natural language processing. Second, he can do some kind of knowledge representation, which is, I guess, the most magical thing that ChatGPT can do, which is to store information in the form of a network. And it also can do automated reasoning. So it can answer questions logically, which is important to convey the message to the judge of the Turing test. And machine learning of course, it's important to adapt to new situations, to guess new patterns, and to adapt over time. That is also something that ChatGPT can nowadays actually already do. Just a small note, Turing said that the machine didn't need to look like a human, and ChatGPT doesn't actually look like a human. It only behaves like one. So this dimension is about behaving intelligently. If you want to talk about other tests, we could talk about the total Turing test, which is a different version of the Turing test that also requires the machine to interact physically with the judge, with the person. And this means that you need to have abilities like computer vision to see what's happening around you. You need robotics to move, to manipulate objects, and you also need to look like a human being. The second approach focuses on thinking like a human. So instead of behaving like a human, we are talking about how we think as a machine. And this raises an important question. Uh, what is to think like a human? Because we are not, of course, we have neuroscience, but we are not sure how to think like a human. Psychologists have tried to do experiments, neuroscientists have tried to understand our brain more. That is also true. But what is to think like a human in terms of a machine? Should we make AI think the same way that psychologists believe people think? Should we simulate how the brain works? This is kind of the approach of neural networks. Should we be able to think about my own thinking? That's an even more deep concept that is the introspection. And over the years, scientists have tried to develop theories of how the human mind works, and they try to implement those theories as computer programs. And we kind of achieved this in neural networks because the neural network tries to behave like a brain. So we can argue that it actually thinks like a human. And this idea is closely related to cognitive science. So, cognitive science combines knowledge from psychology, neuroscience, computer science, and other fields to understand how the human mind works and how to put it in practice. And the ultimate goal is, of course, to build models in a computer that match human thinking. The third approach is called thinking rationally or following the laws of thought. And it's quite interesting because it comes from philosophy, it comes from formal logic. And one of the earliest philosophers to study logic was Aristotle. And he tried to define rules for correct reasoning, so for irrefutable sentences that we could make, arguments that we could make. These rules are based on logical arguments. If the premises are true, they always lead to a correct conclusion. A famous example is the classical syllogism that says that Socrates is a man, and then we can say all men are mortal, and then we can conclude based on the premises that Socrates is mortal. This kind of reasoning is perfectly logical. But the challenge is when the real world becomes much more complicated, right? And information is frequently incomplete or uncertain, so we may not know if all men are mortal. Okay. How we might not know because not we cannot see if all men are going to die. At least in the future, we cannot perceive that. So this is just an example, but some events are unpredictable, and purely logical reasoning is often not enough for solving AI problems. So now we know that, for example, we have ChatGPT, he answers a lot of our questions, but sometimes he's not always right. He has problems of hallucinations, he has problems of not answering things correctly, he has insufficient knowledge sometimes, he has uncertainties, and this means that and this does not mean that he is not acting intelligently. It is if you consider the laws of thought, but in generally, we have the intuition that he might be smart despite of that. The fourth dimension is about rationality again, but it's about behaving in a rational way. So making decisions that are rational. And a rational agent is something, or it is a system that tries to maximize its chances of achieving the goals that it has proposed to do, to achieve. Rational does not mean being perfect, it means trying to be right or being right at most times. It is about making the best possible decision with the information and the resources available at the moment. So we do not expect to know everything. Imagine a self driving car. The goal is to make passengers go from A to B. If a child suddenly runs into the road, the rational action is to brake immediately. But the thing is, the car does not need to think like a human or behave exactly like a human driver. He just needs to choose the safest action according to the goal of safety and protection of the humans in the environment. Instead of trying to imitate humans, which can be difficult because we make a lot of mistakes, we define intelligence as making good decisions, as being rational. But to act rationally, an artificial system has to have some capabilities that are very important, like perceiving the environment, knowledge representation again, reasoning, learning, and also planning. But of course, there are some challenges because, again, in the real world, information is incomplete or uncertain, and we have limited time to make our decisions. And as a result, a rational agent often seeks just the best possible decision rather than the perfect one. And that is why we have the concept of rationality and we have the concept of bounded rationality. Today, the concept of the rational agent is considered the dominant framework in artificial intelligence because we do not ask of machines to think like humans, which is kind of hard to do. We try to make them perceive the environment, to think about it, and to choose decisions or actions that maximize the likelihood of achieving their objectives in bounded time.